All right, this is 12. Today we're doing 12.5 and 12.6. Specifically, this is 12.5, direct variation, and 12.6 is indirect variation. Homework for tonight is page 558, 1 through 18 odd, and 12.6, page 563, 1 through 23 odd. All right. Direct variation is the type of equation that we've been dealing with it quite a bit. It's where one dependent variable, y, is proportional and varies directly with an independent variable, x. It's the type of situation and equation that we've seen before. The way you guys know it is a linear equation. What this means is that y varies directly with x, where k is a constant. It's a constant rate of change. The way you've seen it before is a slope. Okay? You've seen it as a slope. Another example of a k would be, think about the barbecue question. Do you guys remember that? In the word problem, the barbecue question was, he assembled barbecues and he makes $8 a barbecue. So y equals 8x is a direct variation equation where 8 is your constant. It's a constant rate. If I make a few barbecues, I get where y is my pay, x is my quantity of barbecues. Okay? So we're looking for other equations that are direct variation equations, just like this. Would y equals 4x be a direct variation equation?
Yes.
Yeah. What about y equals negative x? Is that a direct variation equation? Absolutely. It's just like the linear equations we did back when. But the only difference with this linear equation, there's no plus something. Okay? What does it mean when it says plus 5? Y equals 8x plus 5. What is that plus 5 in the equation? Rogelio.
Isn't it the y-intercept?
It's the y-intercept. So in direct variation equations, what is the y-intercept? 0. 0. Do you understand? Are you seeing that? Okay? It's a constant times the x is equal to your y, where x and y depend on each other. Number y equals 5x squared. Is that a direct variation equation? No, that's not linear. It will not. Okay, it's a quadratic. It's going to look like a parabola. Y equals 2/3 x. Yes, because it's a constant times the x. What about y divided by x equals 7?
Yes.
Why do you say that, Ben?
Because you can rewrite it as y equals 7x.
Right. If I multiply both sides by x,
Yeah.
I get the y alone, and it becomes a direct variation. If it can be converted to a direct variation equation, it is a direct variation equation. What about y equals x cubed? No. That's a cubic function. It's going to look like this. Direct variations are straight lines, and they go through the origin, the 0. What about y over 3 equals x?
Yes.
Because that can be converted to a direct variation equation. What about y equals radical x? No. All right. Now, the hardest thing about direct variation equations is that they're worded funny. But get away from the funniness of the wording, the awkwardness, and look at it. It tells you how to translate it. The variable y varies directly. When you say varies directly, equals k, and then times something with x. This is your varies directly and x. Whoops, don't write that division bar. Okay? Then it says, when x equals 3 and y is 21, find the value of y when x equals 8. When x equals 3, y equals 21. So I substitute that in. They're basically asking you, find the slope, and then use that constant rate of change to find out when x equals 8. So I'm going to substitute in 3k equals 21. What would I need to do to get the k alone and find that constant? David?
Divide both sides of the equation like this.
And then we get k is equal to 7. Now, what would the direct variation equation be, first of all? That's not the direct variation. That's the rate of change. What is the equation I'm going to use for all possibilities in this type, with this proportional relationship? Yes.
Y equals kx.
Y equals ks, but specific to this proportional relationship.
It's 21 equals k3.
Okay. Let's think about this like barbecues. Remember we said the barbecues are our x and the amount of pay is my y. So here, when I make 3 barbecues, I get $21. What does this 7 represent? What does the 7 represent? Oscar?
The K?
No, but in the word problem, if I make 3 barbecues, I get $21. Christina, what do you think the 7 represents?
How much is sold?
I made 3 barbecues, and I got $21. So what does the 7 represent? Sadat?
Well, that's the price you got for each barbecue.
That's the price per barbecue. So the direct variation equation, the actual direct variation equation, represents any amount of barbecues. What would that equation be? What is the rule for any amount of barbecues? Sarkis.
Y equals 7x.
Perfect. That's I start with this, y equals 7x. This is the direct variation equation. So if they just ask for that, then you stop. But in this case, then it says find the value of y when x equals 8. Let's take it to the barbecue. Find the value of, we said y is your pay, and x is the number of barbecues. So what does this mean, this equation? Okay, what does this mean when it says find the value of y when x equals 8? David?
Okay, well, basically you plug in.
I want to know, what does it mean when it says find the value of y when x equals 8 in terms of barbecues? The barbecue scenario.
That means how much is your pay when you sell 8 barbecues?
Perfect. At $7 each. Do you understand? So they're giving you that second piece. How much is your barbecue if you sell 8 barbecues for $7 each? What will it be? 56. Now, there's 2 ways they can ask this question. They can ask for your direct variation equation, or they can add a second piece to it and have to use your constant rate of change. In this case, our constant rate of change is 7. No matter what, I'm charging $7 a barbecue. Does that make sense? Yes, no, maybe. Thumbs up if it makes sense, thumbs down if it doesn't. Okay, let's try another. Okay. In this situation, it takes 5 cups of flour to bake 65 cookies. How many cookies can be made with 7 cups of flour? Step 1. It's a dependent relationship. What is the dependent? What is the independent? Which variable stands for our dependent and which one stands for our independent? Who can first answer me that? Ben.
The dependent variable would be y.
And the independent.
Independent is x.
So what is my x here?
5.
5. So I'm saying not number-wise, but word-wise. X stands for, define it.
The cups of flour.
Cups of flour is independent, and my cookies depend on how much flour I use. That would be my y. Now we build our direct variation equation. What is it? Everybody.
Y equals kx.
Perfect. Y equals kx. And when I do that, what would I do next? Given the information in that first line. Peyton?
You would substitute in your variable, so your equation would read 65 equals K5.
Good. K times 5. And then we solve for K, divide both sides by 5, and we get K is equal to 13. Okay? Now, what would I do now given the rest of the situation? Okay, David?
I think you plug in 7 for x, and then
Start with the equation. What's the direct variation equation? What direct variation equation can you build?
y is equal to 13 times x.
Y is equal to 13x. Okay? And now what would I do? Michelle?
You plug 7 into x.
Into x because x is our cups. And we get y equals 91 cookies. Can anybody tell me a different way to solve this direct variation problem? This word problem I used last year with my PowerPoints. Sydney?
Proportion.
Yeah. How would you set it up as a proportion?
We would set it for flour over cookies or cookies over flour. Doesn't matter.
Okay, so I'm going to go flour to cookies. Okay, and the first proportion?
5 over 65
5 to 65.
is equal to 7 over x.
Okay. And how would we solve it now?
What I did last year, I just cross multiplied it.
Yep.
So 5x equals 65 times.
I'm going to first simplify because I know that goes, and that'll be much easier. And we just get 13 times 7. 13 times 7 equals x. And that ends up being 91. Okay. So all direct variation equations can be solved as a proportion. Yeah.
Shouldn't the variable that we use be y instead of x?
Oh, you're right. Sorry. But it gets lined up. You're right. We should be using, well, that's only if you've done the defining in that way. Based on what we defined, yes. Tonight, I'd like you to use the direct variation, not use the proportion method, but I wanted you to be aware that proportions are direct variation equations. Okay? Now, let's look at how a direct variation equation looks. What's the y-intercept? 0. So it always goes through the origin. As I set it up, it will make a line. As one item increases, the other is also increasing. If I buy 3 barbecues, I make $3. If I make 5 barbecues, I make more money. If I buy if I make 7 barbecues, I'm going to make $21. Or three barbecues, I don't know. You understand? The more barbecues I make, the more money I make. That's a direct proportion equation. A direct variation equation. the latest buzzword in pre-algebra is the constant of proportionality. It is the constant of proportionality. That's how they want us to teach proportions now, is what is the constant rate of change? It's always increasing. They want us to find the slope, basically. Okay, so let's continue on and look at, let's write the direct variation equation. Do you want me to do one first?
Yeah.
This time, are they giving me a second half to it? No, so all they want is the general rule, like y equals 5x. You have to find your m or your k, and then write the equation. So, do you guys want to try that on your own? I'll do one with you. What would I do first, Oscar? Shh.
Y equals kx.
Good. Keep walking me through it.
Plug them in.
Y equals kx. What am I substituting in?
The 20 and 5.
20.
20 equals k5.
K times 5. Okay, next step.
Like, divide both sides of the equation by 5. Then you get 4 equals 3.
Okay, now, build the equation. What is it? Oscar.
Would it be y equals 4x?
Perfect. That is the answer you put in the answer column. That's it. So, do you understand the difference between this question and the cookie question, where they give you another piece to it? Now, if you write the equation, how do you use it? That's the previous question. This one is just give me the rule. They're saying all that in this silent conversation. Okay, you guys pause the recording and do number 2. Go. Okay, where do I start? Somebody I haven't heard from. Sarah.
First, you start by writing y equals kx, and then you substitute in the x and the y, so it's 18 equals k times 48. And then you divide 48 from both sides, and you get k equals 3 over 8.
We're reducing it, and it reduces to 6 goes into that 3 times over 8. So what would my direct variation equation be, Sadat?
Y equals 3 over 8x.
Did anybody get a decimal?
Yeah.
0.375. 0 and 375 thousandths. All right. There it is. So now we've done 2 things. We've done a couple things. We graphed it. We graphed it, direct variation equations. In this case, they didn't just give us the y and the x, but they made us find the constant rate of change and then use it to find another value. Okay? This one is asking it is just to write the direct variation equation. So this is going to take careful reading in your directions. Your directions are always going to matter. Okay, now they're saying your pinky is proportional to your forefinger. It doesn't matter what it is, but they're saying your pinky and your forefinger are always proportional. That's why, one hand looks similar to another. So think of our forefinger as they're setting it up as our y. Now usually you guys are used to seeing a table if the second one that they're mentioning, that's what we're setting is, take the second one and that's going to be in this situation, it's not really going to matter. They're going to have to present you some kind of information, what would be your y or your x or what depends on the other. So this is all that this is. They said this x is your pinky. By setting it up, it's an x is always on top and y is on the bottom. That's how I know that. Okay? That's how I would guess that. So what would the direct variation equation be? What could I use? What is our direct variation equation? Ben?
Y equals kx.
Where x is our forefinger. Let me just go here. X is the forefinger. X is the pinky, sorry. Okay, so if I do y equals kx, what do they want to know? What do you think they want to know? Ben?
The relationship between the pinky and the forefinger.
So knowing this is a direct variation, what are we missing? K. The number, you multiply the pinky by to always get the length of your forefinger. It's the same number from me to you. It's what makes our fingers, this one, that much big, proportionally bigger. Okay? So to find the K, what would I do? Forget about substituting. What if I just want to get K? What do I have to do, Rogelio?
You just isolate the K,
Right,
you just divide it by X.
right. So K is equal to y divided by x. I can use that right up here. K equals y divided by x. 6 and 5/10 divided by 5 and 4/10. And we get about 1 and 2/100. So if I look at the next person, 1 and 18/100. 1 and 2/10. Pretty close. So we can estimate that the constant of proportionality, or the direct what do they call it? Our constant here is 1 and 2/10. What would the direct variation equation look like? David?
Y is equal to approximately 1.2K.
Close.
No, Y is
Y equals approximately.
1.2X.
Perfect. You said 1.2K.
Yeah, I know.
There you go. So that's the equation that would relate anybody's pinky to their forefinger. Do you understand about direct variation equations? Okay. So that's it for direct variation. Oh no, let's do this. All right. Also, a direct variation equation, as one thing rises, the other increases. Okay? As one thing increases the other. It's proportional. Okay? So, is this situation money collected and hours worked? So money earned and hours worked. Is this a direct variation equation? Yeah. We saw that with the barbecues. What would this be? Money. What would be the independent? What would be the dependent? David.
The money would be the dependent, and I would
Yes, and so money is like your X or your Y?
be Y.
Y. So how would you set that up? Without an X and a Y. Instead with an M and an H. David?
M is equal to KH.
Perfect. That was exactly it. So money depends on hours. So money is earned is equal to a dollar amount times my hours. If I work a few hours or a lot of hours, it's still times the same rate. Distance and the speed of the car, is that a direct variation equation? What's the distance formula? Is that a direct variation equation? D equals RT. Yes, absolutely. In this situation, distance equals rate times time. Doesn't that sound like a y equals kx? They're just using different variables. So they're saying distance traveled and speed of a car. So what would be how would you set this up? Yes.
D equals KS.
Okay, we could say R for
Oh,
rate.
R. Okay.
Now, knowing our distance formula, what do you think the constant stands for in this situation? Sean? Time. Time is the constant in this situation. What about area? Is this a direct variation equation?
No,
No.
Why?
because we're finding something of a shape.
Okay. But what else tells you the clue?
I don't know.
What?
There's no constant.
Yes.
Because it's square.
Because it's squared. Pi r squared.
Oh.
Remember, those are not direct variation equations. Okay? Area equals pi is a constant, k r squared, but because of that r squared, it's not a direct variation. Okay, next one. Circumference.
Yes,
Why?
because there's no squares.
There's no square. What's the formula?
The 2a something. No, I don't. I forgot.
Peyton?
C equals K times D.
Yep. And in this case, what is my k? 3.14 or pi? What about the age of Sam and his brother in 5 years?
Yeah.
What would the equation be? Yeah.
Okay, I got a y for younger brother is equal to s minus 5.
Okay. Is that how you see our direct variation equations? What is the y-intercept on a direct variation equation?
The dependent.
What is the y-intercept on any direct variation?
I thought you said
0. So this has a minus 5. Or plus whatever. There's a plus. So that's not a direct variation equation. Okay? All right, so now let's go to inverse variation. The next lesson, inverse variation.
How would you do the quiz thing?
No.
So you only have like
Okay, I don't know where I left off for inverse variation. I think I need to redo this recording. I put it on pause at some point. Are you working on number 2? Okay, so for inverse variation, go to the next video. I'm going to stop it right now because I already started it. There will be another video for 12.6.